Welcome to the lecture on bomb calorimeter. In the earlier lecture, we had discussed about Junker's calorimeter and Boy's calorimeter. Using that two calorimeters, we can determine the calorific value of gaseous fuels and the liquid fuels which can be easily vaporized. Now, we will discuss about bomb calorimeter. Bomb calorimeter is used to determine the calorific value of solid fuels as well as liquid fuels. So, first coming to the principle. Here we will be taking a known weight of sample, nothing but known weight of fuel. The fuel will be burnt. Due to burning, heat will be liberated. The liberated heat will be absorbed by water. So, the heat absorbed by water will be measured. From this we will be determining the amount of heat that will be produced by burning unit mass of fuel. From this we will calculate the amount of heat produced by burning unit mass of fuel. So, now coming to the description of this method. So, the bomb calorimeter mainly consists of a bomb. This is the steel bomb which is covered with a lid, and it consists of a copper calorimeter, air jacket, water jacket and an inlet for oxygen valve. So, this in detail we discuss in the construction of bomb calorimeter. So, bomb calorimeter mainly consists of a cylindrical vessel. So, this is the cylindrical vessel which is made up of stainless steel. So, that is why we will call it as stainless steel bomb. In this bomb, the combustion of the fuel will be taking place. So, this bomb is covered with a lid. So, this lid is screwed to cover the body of the bomb so that it will act as perfect gas tight seal, and the lid is provided with two electrodes. So, these are the two electrodes and an oxygen valve. Now, the fuel will be taken in this stainless steel crucible. A magnesium wire will be fused, or it will be framed around this one, which is connected to the electrodes which are in turn joined to an external battery. Now, this entire bomb is placed in a copper calorimeter. So, this copper calorimeter consists of known weight of water. The copper calorimeter is surrounded by air jacket and water jacket in order to prevent the heat loss due to radiation. and a standard thermometer, we can call this as Beckman thermometer. It is dipped in this copper calorimeter to measure the temperature of water, and an electrically operated stirrer is also dipped in the copper calorimeter for stirring of the water. So this is about the construction of bomb calorimeter. Now coming to the working. Here, a known weight of sample will be taken in this stainless steel crucible. Now, this magnesium fused wire is dipped in this fuel, which is connected to the two electrodes, which are in turn connected to the external battery. Before that, the fuel is taken in the stainless steel crucible and it is covered with the lid, and now this bomb is placed in the copper calorimeter, which containing known weight of water. Next, the temperature of this water is noted after thorough stirring. After that, the magnesium fuse wire will be connected to the electrodes and in turn connected to the battery, so that the fuel starts burning. So during this combustion process, heat will be liberated and the liberated heat will be absorbed by the water in the copper calorimeter. So like this, the uniform heating will be continued and the temperature at which the maximum can be attained, it is noted. From this we can calculate the calorific value as follows. Let the weight of fuel be some x grams. Weight of water, which we are taking in the copper calorimeter, let it be some W grams. Next, weight of water equivalent, let it be some W grams. Here water equivalent means it is the weight of instrument plus specific heat, that is called as weight of water equivalent. Let initial temperature of water be some T1 degrees centigrade. Final temperature, that means the temperature of water after complete burning of fuel, be T2 degrees centigrade. Let HCV or GCV, gross calorific value or high calorific value of the fuel, be some L. Now, heat gained or heat produced, we can say heat produced by burning of the fuel will be X into L. That means weight of coal sample into high calorific value. Next, heat gained by water will be equal to weight of water into specific heat of water into T2 minus T1. Here directly we can write it as weight of water into T2 minus T1, since specific heat of water is 1, where S is specific heat, which is equal to 1. Now, heat gained by calorimeter is equal to weight of water equivalent into specific heat into T2 minus T1. So this will also be equal to specific weight of water equivalent into T2 minus T1. So total heat gained will be equal to weight of water into weight of water equivalent W plus W into T2 minus T1. So total heat gained will be equal to weight of water plus weight of water equivalent into difference in temperature, final minus initial. We know that heat liberated or heat lost will be is equal to heat absorbed or heat gained. That means XL is equal to weight of water plus weight of water equivalent into T2 minus T1. From this, the gross calorific value L is equal to weight of water into weight of water equivalent into T2 minus T1 by X, where X is the amount of the fuel we are taking in the bomb calorimeter for combustion. So this is the formula for calculating the gross calorific value of a solid or liquid fuel using bomb calorimeter. But the calorific value what we are determining by this method is not the accurate value. Why means some corrections are to be done here. What are that corrections means? First one is fuse wire correction. So fuse wire correction means whatever the heat that is produced also includes the heat that is being produced due to the ignition of the fuse wire. So while burning this fuel, along with that this fuse wire will also be ignited at that temperature and pressure. So that's why the heat produced due to this ignition should be subtracted from the calorific value. So fuse wire correction should be subtracted from the calorific value. Acid correction. Acid correction means in general fuels will contain hydrogen, sulfur and nitrogen. So these constituents in the fuel at the high temperature and pressure prevailing in the bomb calorimeter these will be oxidized to form sulfuric acid and nitric acid. I'll show you here. Sulfur existing in the fuel will combine with the oxygen which is coming from the inlet valve of the bomb calorimeter, and it will give rise to sulfur dioxide. So this sulfur dioxide again combines with oxygen and forms sulfur trioxide. Hydrogen existing in the fuel will combine with oxygen and forms water. Now, water and sulfur trioxide will combine and form sulfur trioxide, sulfuric acid, H2SO4. The formation of sulfuric acid is an exothermic reaction. So this reaction is exothermic reaction. So the heat produced also includes the heat liberated during the formation of sulfuric acid. That means due to the exothermic reaction. Similarly, the presence of nitrogen in the fuel forms nitric acid. This is also an exothermic reaction. So that's why acid correction values should be subtracted from the calorific value. Next one is cooling correction. So while determining the calorific value, the water in the copper calorimeter will be stirred and some amount will be vaporized. During this time, the temperature of water will be, or the heat will be reduced. So that means it will be cooled. So cooling correction should be added to the calorific value. That means the actual formula for calculating the GCV using bomb calorimeter is weight of water by plus weight of water equivalent into T2 minus T1 by X. X is the weight of the fuel. Here fuse wire correction should be subtracted, acid correction should be subtracted from this calorific value, and cooling correction should be added to the calorific value. Due to these corrections, the gross calorific value will be weight of water plus weight of water equivalent into T2 minus T1 plus cooling correction minus fuse wire correction plus acid correction by X. So this is the gross calorific value formula using bomb calorimeter by considering the corrections. So now we will practice a problem on this. Solution. So the problem given is about 0.98 gram of a fuel when burnt in bomb calorimeter increased the temperature of water from 1.8 degrees centigrade to 3.6 degrees centigrade. If the calorimeter contains 1450 grams of water and water equivalent is 450 grams. Calculate the HCV and LCV of the fuel if the fuel contains 8% of hydrogen. So here first we will write down the given data. Weight of the fuel. Weight of the fuel means X. It is given as 0.98 grams. So when it is burnt in a bomb calorimeter, the temperature of water is increased from 1.8 degrees centigrade to 3.6 degrees centigrade. That means initial temperature of water T1 is 1.8 degrees centigrade. Final temperature of water T2 is 3.6 degrees centigrade. Next, weight of water. Capital W is equal to 1450 grams. Next, water equivalent. Weight of water equivalent, that is small w is equal to 450 grams. So by using this we can calculate the HCV. So the formula for HCV is weight of water plus weight of water equivalent into T2 minus T1 by X. Substituting these values, 1450 plus 450 into 3.6 minus 1.8 by X is given as 0.98. So this will be equal to 3489.8 calorie per gram. So this is the value of high calorific value. Next, what he has asked, LCV of the fuel if the fuel contains 8% of hydrogen. So now we will use the LCV formula. So lower calorific value is equal to higher calorific value minus 0.09 into hydrogen, that is nothing but percentage of hydrogen, into latent heat of steam. Latent heat of steam is 587. Substituting this, 3489.8 minus 0.09, percentage of hydrogen is given as 8 into latent heat of steam 587. By simplifying this, we will be getting 3489.8 minus 422.64. This will be equal to 3067.16 calorie per gram. So this is the value of lower calorific value. In the next video, we will discuss few more problems on calorific value. Thank you.